Hello and welcome to Otten Math. In this edition of Otten Math, we're going to talk about properties of rational exponents. Right, so I'm going to put up this slide. It's just a figure for you to write down all the properties. You can take a moment here. I'm going to pause it and then we'll move on to go through examples and classwork for each of the different properties. Right, so first we're going to talk about the product of the powers. Product of the powers is when you're multiplying two bases together that are the same but have the same or different exponent values. In this case, you're going to add the exponents together and keep the base the same. So the example is a to the m times a to the n, so the base a is the same. M and n are the two exponents, and you're going to add m to n to come up with a singular value for the exponent a to the m plus n. So let's take two examples. A to the 1/3 times a to the 3/4. Right, the bases 8 are the same, so we're going to add the exponents together, 1/3 and 3/4. I have to find a common denominator of 12. We end up with 4/12 plus 9/12, which is equal to 8 to the 13/12. And then 7 to the 1/2 times 7 to the 3/2. Again, bases are the same, 7. So we're multiplying the two values together. So we're going to add the exponents, 1/2 plus 3/2 leaves me with 4/2 or 2. 7 squared is equal to 49. So this is how it should look. All right, so now I'm going to go on to some classwork problems. I want you to complete these problems and I'll show you the answers. Okay, I'm going to pause here while you complete this work. All right, so again, product of the powers, same base. We're going to multiply one value times another with the same base, and we end up adding the exponents together. In case number one, problem number one, 1/2 plus 6/4 is equal to 8/4, or 2. 6 squared is 36. Example number 2, 4 to the 5/2 times 4 to the 1/2. 5/2 plus 1/2 is 6/2 or 3. 4 cubed is 64. Last example, 9 to the 1/3 times 9 to the 1/6. We end up with 2/6 plus 1/6, or 3/6, or simplified to 1/2. 9 to the 1/2 is the same as the square root of 9. Square root of 9 is 3. Okay, second property, power of a power. So we're going to use this when we have a term or value that's taken to a power, and then that entire value is taken to another power. So it's power of a power. In this example, a to the m taken to the n means we can simplify by removing the parentheses and then multiplying m times n. So we end up with a to the m times n. And let's go through an example. So 3 to the 1/3 to the 2/3. We're going to take 3 to the 1/3 to the 2/3. Multiplying 1/3 times 2/3 is 2/9. So 3 to the 2/9. And there's nothing we can do from here. Next example, 5 to the 1/4 to the 1/2. Multiplying 1/4 times 1/2 is 1/8. 5 to the 1/8. And then the last example is 3 to the 6 to the 3/2 to the 2/3 ends up being 6 to the 6th over 6, which is 6 to the first power of 1, and we end up with a value of 6. So here are the results from the examples. Again, we're going to use it when we're taking some value that has an exponent already, and we're taking that value to another exponent or power. We're going to multiply the two exponents together and remove the parentheses. So here are some classwork examples for you. I will pause here, and then you can check your answers. Okay, number 4 ends up being 3 to the 6/2, or 3 to the 3rd, 27. Case number 5, or problem number 5, 1/3 times, actually 1/3 plus 1/3, so we have 4 to the 2/3, so we're going to use product of a power first, and then we're going to use power of a power second. So 4 to the 1/3 times 4 to the 1/3 is 4 to the 2/3, taken to the power of 3/4 ends up being 2/3 times 3/4, or 6/12, or 1/2. 4 to the 1/2 is 2. 16 to the 1/4 squared is 16 to the 2/4. or 16 to the 1/2, which is 4. All right, property number 3, power of a product. So power of a product is when you have two factors or a product taken to a power. You can separate the product into its factors and apply that given exponent to each of the factors. So in this case, a times b, a product to the m, is equal to a to the m times b to the m. And of course, it can work in both directions. So if you have two factors, so different bases with the same exponent value, you can consolidate those into a product with a singular exponent. All right, so example, 16 times 9 to the 1/2. We can rewrite this as 144 to the 1/2, which is 12, or we can write this as 16 to the 1/2 times 9 to the 1/2, which ends up being 12 as well. So there's your example. I'm going to give you a couple classwork problems. I'm going to pause, and then you can check your work. All right, answer is 3 to the 1/4 times 27 to the 1/4. So in the first case, we are going to, we can either multiply the values together and then take them to the 1/4 power. In this case, what I did was I reduced 27 to 3 to the 3rd and then used power of a power, and then used power of a product to come up with a value of 3. Problem number 8, 5 to the 1/3 times 25 to the 1/3 is 125 to the 1/3, which is 5, and then 64 to the 1/2 times 9 to the 1/2. I end up with 64 to the 1/2 as 8, and then 9 to the 1/2 is 3, multiplying those together. So I could have taken 64 times 9 to the 1/2, which would have ended up being 576, square root of 576, which is also 24. So again, you can use power of a product in both directions, either evaluating each of the individual expressions, then multiplying, or taking the product of the two factors with the same exponent and then evaluating from there. All right, negative exponent, property number 4. When to use when you have a negative exponent. We need to know that simplified expressions can't have a negative exponent. So when we rewrite or simplify any expressions with exponents, those exponent values need to be positive. So an example here is a to the negative 1 is the same as 1 over a to the first power. So in this case, what negative exponent means is not that we're applying a negative sign in front of the value, but we're taking the reciprocal of the value that has the negative exponent, and then we're applying the absolute value of that exponent to that value. So a to the minus 1 is the same as 1 over a to the first power, 1 over a. Next example, a to the negative 2 is 1 over a squared. Number 2, 2 to the negative 2 is 1 over 2 squared, or 1 over 4. And then the last example, 1 over 2, the negative 2 is 2 over 1 squared, or 4. And here are the results. You can check your work. I'm going to give you some examples to handle as classwork while I pause, and then you can check your work again. Okay, so we're going to check your work. 1/3 to the negative 3, so we're going to take the reciprocal of 1 over 3, which is 3, cube it. 3 to the 3rd is 27. 3 to the 1/3 times 3 to the 5/3. So what we're going to do here first is use our properties to consolidate the values in the parentheses. 3 to the 1/3 times 3 to the 5/3. We're going to add the exponents together. The bases are the same. I end up with 1/3 plus 5/3 or 6/3, which is 3 squared, or 9. And then I'm going to take 9 to the negative 2. So that's 1 over 9 squared, or 1 over 81. Number 12, 5 times 1/2 to the negative 3. So in this case, I'm going to use my order of operations. I'm going to apply my parentheses exponents first. So 1/2 to the negative 3 would be 2. So the reciprocal of 1/2 is 2 cubed, which is 8. And then multiplication, division, addition, subtraction. 5 times 8 is 40. Okay, property number 5, quotient of the powers. So I'm going to do this. I'm going to use this property when I have bases of the same and the exponent is different or the same. In this case, what I'm going to do is I'm going to subtract the exponent of the denominator from the exponent of the numerator. So 3 to the 5/3 divided by 3 to the 2/3 is the same as 3 to the 5/3 minus 2/3, or 3 to the 3/3, which is equal to 3. 4 to the 2/3 divided by 4 to the negative 1/3 is the same as 4 to the 2/3 minus a minus 1/3, or 4 to the 2/3 plus 1/3, 4 to the 3/3, or 4. So again, I'm going to give you a couple examples. You can do this as classwork and then check your answers. Okay, 8 to the 1/4 minus 1/4 minus a minus 1/4 is 81. Excuse me, 81 to the 1/4 minus a minus 1/4 is 81 to the 1/2. 81 to the 1/2 is 9. 4 to the negative 3/4 minus a minus 5/4 is 4 to the 2/4, which is 4 to the 1/2. Square root of 4 is 2. Last example, number 15. That's 4 to the 5/4 minus 1/4, or excuse me, 7 to the 5/4 minus 1/4, which is 7 to the 4/4, or 7 to the 1, or 7 to the first power, which is 7. Okay, the last property, we're not going to talk about applying an exponent of 0. We're just going to, I'll re-review that very quickly before we finish here. But the last one we're going to go over with examples is power of a quotient. We're going to use power of a quotient when we have two bases that are different, but an exponent that's the same. So we can take the numerator and denominator and separate those out into their own values and apply the exponent. Or we can take that quotient and apply the exponent. It works again in both directions. So a over b to the n is the same as a to the n divided by b to the n. So 27 divided by 64 to the 1/3 is the same as 27 to the 1/3 divided by 64 to the 1/3, which ends up being 3 over 4. 27 to the 2/3, 27 over 64 to the 2/3 is the same as 27 to the 2/3 divided by 64 to the 2/3, which is 9 over 16. So again, I'm going to move to classwork examples. You can check your work. Okay, 81 over 16 to the 1/4 is the same as 81 to the 1/4 over 16 to the 1/4. 81 to the 1/4 is 3, 16 to the 1/4 is 2, 3 over 2 is your answer. Number 17, I can separate 64 over 27 into, to the 1/3 is 64 to the 1/3, divided by 27 to the 1/3, which is 4 over 3. 125 to the 1/3 divided by 8 to the 1/3, which is 5 over 2. All right, so now we're going to go back briefly to our seventh property, which is the zero exponent property. So if you have any value to the power of 0, it's going to end up being equal to 1. All right, so we're not going to have any examples for that particular problem, for that particular property. All right, so a couple things to remember. You need to know your order of operations, parentheses, exponents, multiplication, division, addition, subtraction. So in this case, 5 times in parentheses 1 plus 8 squared plus 5. We're going to handle our parentheses first, adding the two values together, taking them to the power of 2. So 5 times 9 squared, which ends at plus 5, ends up being 5 times 81 plus 5. So parentheses, exponents, and multiplication. 5 times 81 is 405, and then addition, 405 plus 5 is 410. Second thing is simplified rational exponents means it has no negative exponents. There are no power of powers. There are no integers with exponents. Of course, variables, letter variables can have integers applied to them and retain the integers in simplified form, and all like terms are combined. And lastly, power of a sum or difference versus power of a product or quotient. If you have a power of a sum, you need to add the values together before you take the power. So let's take the example 4 plus 3 squared is not the same as 4 squared plus 3 squared. 4 plus 3 squared is 7 squared. And 4 squared plus 3 squared is 25, so you can see that that's not the same.